do is I record this
Okay.
and then I'll download it, and I don't know how I do it. I think I put it on YouTube, but I put it private where only you can see it, and then you can go back and you can review this.
Okay.
So,
Now,
excellent. Excellent. And so I've got mine sitting right here too. So we'll definitely be going over those steps, where those steps are located and how they're going to go, how they're going to
Okay.
be used. So let me share my screen with you. And I'm hoping you can see something that says motors and it has two pictures of motors on it. You see
correct.
that? All right,
Yeah.
cool. All right. So what we're gonna do is we're gonna burn through this this little section right here, and this is all this is highlighting the code section, and this explains to you where those 6 steps come from.
Okay.
Like I said, since it's being videoed, we can go over them right now, and you can go back and watch them and then highlight them in your book if you want. So
Okay.
I'm not wasting your time highlighting your book when you can go back and highlight later on.
Well, I mean, your YouTube videos, the 6-step process, the 3
Right.
videos.
Right.
I should have most of that already highlighted.
Okay. Okay. And that's
if
where
we have time and I can't find my separate tabs,
I
bought some tabs at Walmart.
Okay.
I wanted to just get your input of going back and just doing my own personal quick tabs at the top of the book.
Right.
Because in the test, I went right down to the minutes. I mean, I had to go back and
Sure.
pick up the last few questions and make wild guesses.
Okay.
But I mean, I was right down to the wire, and I had one bathroom break. So I mean, I didn't waste no time.
Good. I mean, that's that means you didn't just fly through it and guess and be all right, that's it, you know. You worked it. So
Yes.
okay. Well, let's start in 430 real quick.
Okay. I'm here.
And right there, table of values. And those are the values in the back, that the 400, 247, 248, 249, 250. That's all the FLC stuff in the back. Are you familiar? Do you have that tabbed? Those tables tabbed?
What were they again?
They're the tables in the very back, the 430, 250, 249, 248. It's your 3-phase motors, your single-phase motors, your DC motors, all that stuff.
Let's see. Let me get there. 430 to
430, and it's in the very back. It's right before it changes. Or 230, 240. And did I say 430? I'm sorry. Yeah, 430. I'm sorry.
Yep, I have 430, 250.
Exactly.
Below 3-phase, I had that.
Okay.
430, 247, I had that noted in red as DC.
Yep. And 248
48 is AC.
Single phase.
Uh,
Is it single phase? I'm just guessing off of here.
Full load current amperage, single phase. Oh yeah, AC.
Yes, sir. Yes, sir. All right. Those are very crucial in this whole thing. In fact, that's step number 1. And if we can't do step number 1, we can't build the house. You know, that's the first block in the foundation that we build for this stuff. So right here, that's telling us where all that stuff's coming from in table values. And just a little, everything's based on the full load current, and this is just justification of what we do, and I'm just kind of pointing it out. Like I said, go back and reread it or rewatch this, and it'll start making sense. The big thing about 430.22 is continuous, not continuous, but a single motor. You have to rate it at 125%.
Right. And any motors after that, you take them for the face value.
Gotcha. Yep, you got it. And then we've got a
Yeah, I
table
beat that
here.
in my car.
Right. Um, and then your different duty cycle motors are in 430 22E.
Correct.
Okay. Great. I'm burning through this because you've seen these before. I just want to make sure you haven't missed anything. Here again, when we're putting several motors together in a situation, we take the first 125% of the first one and then the sum load of the second or third or fourth, which you've already stated.
Hmm.
Did you happen to have a swimming pool situation come up where you had to figure out the pump motor, the jacuzzi motor, and then they put some lighting loads on there?
On the test, no, but probably just in my own testing, I want to say yes.
Okay, so this is where you use that. So say it's the jacuzzi motor, and then you've got the pump motor, or there's two motors in there. Maybe it's a heater. So you have to put the heater right here,
Okay, so
and
the
then
heater will be at three.
right. And then
Okay.
there's sometimes they throw a lighting load in there and you have to use that too at 100%. So it's usually the lighting load or the heater mode that throws everybody off because it's not a motor, and you're like, and they don't tell you it's not a motor, but of course it's just the heating element. So make sure you use that right there at number 3, that 100% of that. If you
Okay.
see that, if you see it.
All right. So heater and lighting and anything else they throw is step three at 100%.
Right. Exactly. Exactly. All right. General part 3, motor overload. Now remember, overloads and overcurrent are two different things. So in part 3, we're talking overloads. So the heater portion of are you familiar with the heaters? Not a heating element, but the overload protection.
Like diffuses.
No, sir, that's overcurrent.
Okay.
Overcurrent is your fuses. Overload is have you been around heaters where you walk up to the panel and you push a reset button because the heater tripped or the overload tripped? Have you ever had that situation?
I can't say
Okay.
that I have.
Okay. Overloads, just remember, overcurrent is a quick situation. It's a ground fault situation. So it's quick. It's your breaker that's tripping. It's your heater, or not your fuse that trips.
Okay.
Your overload, and I believe that's step number 2 in your diagram there, or whatever, my flow chart that I had there. And it's a slow trip is what it is. It's literally what causes it is the varnish on the windings of the motor. They finally start kind of wearing out, and it causes heat. So there's an overload in there that senses that, and it slowly trips. It's not an instantaneous. It's probably maybe a 10 or 15-minute operation that trips those heaters.
Okay.
So that's your overload. Now your overcurrent protection is your breaker, or your fuse, and it's a quick ground fault. It's quick. It's
Right.
going to happen quick. So your overload is your heaters or your overcurrent overload protection. And I'll show you there's a specific way to figure that setting out, and that's usually a test question here. So if you go to 430.32, number 1, this is the percentage of how you break down your how you set your overload protection, and it's based off of your FLA.
Okay.
And what I really got to stress is this right here: round down. Make you a little note right in here somewhere in your book to round down. Don't round up, round down. And what that means is when we work all this stuff out, we automatically round down, not up to the next one. We round down because we want it to be, think of it as you want it to be more sensitive. You don't want it to burn and then finally trip out. You want your motor to get hot and then your overloads to trip before it burns your motor. So you want your overloads to trip before your motor burns, kind of thing. And that's the
Okay.
way this bald head of mine thinks, you know, just some weird stuff. Just remember, round down.
Right. Because I have all that highlighted.
Uh-huh.
Then 125% multiply 1.25 multiply
Mm-hmm.
115 or 115 at 1 point or at 0.115.
Right.
Then I have LA. Then I just made a note of rounded down.
Yep. Yes, sir. Yes, sir.
So,
Next highlight. Shall be capable of carrying the starting. Okay, so I don't know if did you do a lot of code? Did you see code motors in your code portion of your test? Because this is more of a code question, not more of an operations question. So,
no. See, our test in Virginia was 90 questions,
mm-hmm.
but from what I remember, we probably had 8 to 10 questions from the state
Uh-huh.
renewing your license.
Right. Oh yeah.
Yeah. So if you're used to test having 90 questions, I probably had 80.
Gotcha.
So they probably cut some of them out.
Gotcha. Okay.
Which I mean, I'll email you that book for Virginia. So if you ever tutor anybody else for
Oh,
Virginia,
okay. Appreciate it. Yeah, because I know same thing on my Texas Masters. You know, there's a portion of business. You know, they want to know how big of the letters you have to have on your pickup if with your license and all that. You know, it's just
really,
business stuff. Oh yeah,
yeah.
it's
These
great.
were you at what age can you apply for a license? 18. At
Yeah.
if you get convicted of a misdemeanor or felony, you have 30 days to notify them.
Right. Right.
So I found most of them pretty quick, but I've gone back to that book and kind of paper clipped a lot of the
Right.
elevator, the plumber, and I got rid of that stuff.
Sure. All right. So on table 430.5052, the big thing here is the round up.
Okay.
Just write you a little note, round up.
Round up.
Round up. And that's on
Okay.
your different, you'll get questions about a non-time delay or a delay or an inverse time breaker or something in there. You know, they throw these words in there throwing you off, but actually they're telling you exactly where to go in your code. But if you don't know where they are on that table, you're going to be thrown for a loop on that.
Okay.
Most parts motor protection shall be permitted. That's another code question. Since you're not too concerned about that, then we're going back to our tables.
And that was
Which
3055.
yes, sir. Yes, sir.
Okay.
And then here's our tables that you already went back to earlier. We got the single phase, the DC, back in there. Here's another 250. Let me see. That's just the breakdown of that. And I'm kind of skipping, I'm taking advantage of your knowledge that you've already taken the test. But here's a big thing right here, Mike, is your FLC versus your FLA.
Yeah, I remember you FLC.
FLC is in the code. So think of it as full load code. That means go back to your code book and look in your tables. If they're asking for FLA And the only place they will ask you for the FLA is your overcurrent protection. Oh, I'm sorry. Stop. Overload protection. And that's the actual motor nameplate. You have to go to the motor. So the full load actual. So you'll have to go exactly to your nameplate on when they're asking FLA for overload protection. That's the only time they're going to ask you for FLA is overload protection.
Okay.
FLC, full load code. That means go back to your tables in the back, 250, 248, 247, depending on DC, single phase, whatever.
Okay. Yes, I can remember motors, back of the book.
Yep.
Hit
Yep.
those tables highlighted.
Yep. Yep. And we'll get you taken care of on your doctoring up your book a little bit so you can get to it right away. There's table 430, 248, and that's for your single phase AC motors. And are you comfortable with the table itself, reading it and knowing how to use it?
Yeah, I mean, 115 volts is typically 120.
Right.
I think you made a note that never seen a 200 volt system.
Yeah. Yo. I don't.
208 and 230.
Yeah.
We're not going to see a 277.
Not on single phase. So, I mean, there's a little simple question. The FLC of a 1 horsepower, 15 volts, single phase motor. And this is just a little exercise to get you to use 248. So it seemed like you already had it down pretty much. You knew how to use it.
Motor?
1 horsepower. Mm-hmm.
Yeah, 1 horsepower. I see. Here's where I struggle because I'm going into panic mode.
Oh, no. Relax. This is where we relax. You need to right here. If you're panicking, just relax, get it right, because speed's gonna come with time.
See, I was going the wrong way in the code book because I'm looking for 430, 248, and
yeah.
So 1 horsepower, 120 volt. Yeah.
So
it's right there.
It's what? It's 16 right there.
16 right there.
Yes, sir. Just relax. I know exactly how you feel because I've taken some of these courses before and they start throwing questions at me and all of a sudden I just panic. No, we'll just relax.
When I went through the test, I kicked all them questions to the end. Marked them, breezed through them. I started looking at the clock. I'm like, oh wow, I got 2 hours left. I'm, 5/8 the way through.
Right. Yeah.
And all of a sudden you look up, it's like, holy shit, where'd that hour go?
Exactly.
Then I'm sitting there, I got to go to the bathroom. I got to pee.
Yeah.
And all I, fix on was having to go to the bathroom. And finally, it's just like, just get up and go.
Yep. Yeah. Because that's all you're thinking about. I got to go. I got to go. Well, let's just go and get it over with. Let's go. So here's another one. FLC. So remember, it's FLC. So it's full load code. So we go back to our tables. Single phase.
Yeah, that'd be 32.2. Yep.
Yes, sir. Yes, sir. And what I'm going to do, I'm just going to flip through this. So this is on your video and you can go back and change it. What I strongly suggest, Mike, is you start, when you study, change this around. Change your horsepower, change your voltage around just for studying purposes, just so you can get used to flipping through.
Okay.
It's real easy.
Or at 208, that would be at 30.8.
Right. Yep. Exactly. So here's another single phase 5 at 230.
Yep, that'd be 28.
There you go. You got it. Now let's go to, excuse me, let's go to table 250. and that's where it's the three-phase motors. Where I believe it says up there on 250, it says it's a polyphase, so it should be like either one page over, and it's a bigger looking table.
Yep, full overcurrent, 3-phase alternating current motors.
Yes, sir. Same thing. 5 horsepower, 230-volt, three-phase motor. Do the same here.
15.2. Yep.
Yes, sir. And that's where I don't know what you're allowed in your test, but I always had me a straight edge or a piece of paper just to be able to stay right on the horizontal plane across these tables and stuff. Just a tip.
Yeah. They wouldn't let me have the ruler.
Uh-huh.
But he gave me a couple extra pieces of scratch paper with their letterhead on it.
There you go.
And I just right in half.
Yep. Exactly.
Yeah, so.
And there's another one.
25.208.
25.
74.8.
Yep. Yeah, you're getting it. All right. Now this is going to be step 2. So what we did is we actually went through step 1 of the flow chart here. Now we're getting into step 2.
Okay.
So the overloads, and we already went over that table.
Okay, the motor nameplate, 75 horsepower.
Yes, sir.
230, 460 volt.
Yes, sir.
Average 168 to 84.
Right. Right.
We have to figure out what we're wiring this motor to.
Right. So if they're asked, did you get something like this? What's the FLA of the motor?
I don't remember that one.
Okay. Like I said, I'm just getting this on your video. And what you do is you take the FLA equals the horsepower. For each horsepower, there's 746 watts. And you divide it, divided by the voltage, and that's the efficiency and the power factor. So if you get something with efficiency and power factor, this is the equation to which you use.
Okay.
What I do, I make sure I take this equation in there with me, and I put it in my book. So wherever there's got to be a section within your book that has some good information that you take with you in. And this is one of the equations that that you need to make sure you get in with you.
Okay, I'm putting it in the back with that other flow chart.
There you go.
Now, where do we get to 746 at?
746 watts. Where is that? That is an, it's not Ohm's law. There's another law, and they figured out that that's their equation of 746 watts per horsepower. Horsepower. So if you have a 1 horse motor, it's actually 746 watts. So that's a math. That 746 is a commonly used number when it comes to motors. That's a motor number.
So for every horsepower, it's 746 watts.
Yes, sir.
Okay.
Yes, sir. So there again, say we don't have power factor or efficiency, but you know the wattage of the motor, you can take that, and if you know your horsepower, then you know your FLA. There's questions there where you have to work just this section of the equation, 746 times your horsepower, and they want to know what your FLA is.
Okay.
So just wanted to get that introduced to you. So your question would be something like this. What is the nameplate full load amperage of a 1 horsepower, 115-volt rated motor having the efficiency of 70% and the power factor of 70%? So what we do is work that equation just like that and come up with 13.2 amps.
Okay, so it's 746 times 1 horsepower, because that's what
Yes,
the
sir.
motor is.
Yes, sir. Divided by your
Your
voltage, and then your efficiency, and then your power factor.
So it's 746 divided by 115. That's 6.49. Then times 0.7.
Yes, sir. Let me do this real quick.
Then times 0.7 again. I didn't do something right.
Did you get 56.35?
No, I got like 3 something.
Okay, so 115 times 0.7 times 0.7 equals 56.35.
56.35.
Yes, sir. Now you take 746 and divide 56.35 into it.
740. Yeah, I got 13.23.
There you go. Right there.
So in your down, you said?
Yes.
Okay.
Well, on that one, you're gonna have to watch whatever option, because you've got four options, right? 4 guesses, A, B, C, or D.
Right.
On your so you're gonna see something like right in there. Don't get too hung up on the hundreds or the thousandths place past your decimal.
Okay.
That doesn't matter. They're looking for this right here.
Right. So that's the full load, the FLA.
Yes, sir.
Okay.
Yes, sir. Yep.
So I need to write that equation down in the back of the book too somewhere.
Well, that is your equation that you wrote, but that's it right there.
Right there.
That's that equation right there.
And where do we get the 0.7 at?
It's in your question.
Gotcha. So that was the percentage. Okay.
So remember, anytime you see a percent, well, I can't say anytime. 9 times out of 10, when you see a percentage, it's going to be a multiplier. So it's 125%. It's going to be 1.25. 70% is going to be a 0.70. You know,
Gotcha.
just remember remember that whenever you see a percentage, it's usually a key to multiply.
Gotcha.
Because you got to factor in this. You know, your 0.7, so you're adjusting. All right. We'll do. You want to work on this one?
Yep. So it's a 5 horsepower motor.
Let's see, 5 horsepower motor at 230 volt with the efficiency of 80% and a power factor of 76%.
Okay, so the 5 horsepower motor
times your wattage. Remember the wattage?
Yes, 746. So
yes, sir.
5 times 746 is 3,730.
Yep. You can put that off to the side.
Yep, got that. Then it's going to be voltage.
Right.
Times 230 times 0.80 times 0.76.
Yep.
That's 139.84.
Yes, sir.
So we're going to do 3730 divided by 139.84. 26.67. There it is.
You
Nice.
got it. You got
Now,
it.
now if I
I
can just
like that
remember,
smile on your face. I like that.
now if I can just remember that.
Oh, you will. You will. It'll just come with time with, a little practice and you got it. We got it. Now, since we've got single phase motors, the only thing that changes with a three-phase motor is we've got to use the square root of 3 right in here, 1.732.
Okay.
This square root gets used a lot when we deal with three-phase. Not just in motors, but like in transformers also. We use a 1.732 with that.
Okay.
So that just added one more step in our equation compared to single phase. Whoa. Oh, that was a funky misspelling. Let's see, what is the full load amperage of a 75 horsepower? And it's going to be like this 230, 460 volt rated motor having the efficiency of 91% and a power factor of 92. So as soon as we see 460, we know it's three phase.
Gotcha.
And then we'll come in here and work the math. Just like this, we take our wattage times our 75 horsepower, take our voltage, our lower voltage, times 1.732 times efficiency times power factor.
All right. So 75 times the 746 is
Yes, sir.
55,950. Then we're going to take our 230 volt.
Yes, sir. Times the square root of 3, which is
1.32, which is 398.36. And times
times
0.9,
10.91.
then times 0.92.
Yes, sir.
I got my hand covering up the answer. I don't want to see the answer.
Okay.
And that's 33 or 333.5. So 55,950 divided by 33.5, 167.76.
I flipped the screen for you so you wouldn't even cheat yourself. There you go.
So
Just round it
you
up.
got, yes, you got 168 on it.
Mm-hmm.
Okay. So got to remember the square root.
Every time you see three phase, anytime you see three phase, remember square root.
Okay.
There's always a square root in there.
Square root 1732.
And remember, if you can't remember what the square root of 3 is, your calculator should just do it. You just put 3 in the square root sign.
Let's see, 3 and
There's a square root sign on it.
I don't see it.
Let me see. A little.
Yeah. Can you see the cut?
Yeah. Can you scoot it over a little bit more? Let me a little more. Wow. I can't
I don't know.
see it good. Wow. Well, I'll tell you what, just put that in your notes. You know, square root of 3 is 1.732. But if you do they give you a calculator or can you bring your own?
They did give me a calculator. Square root's that sign, right?
Yes, sir.
Okay. No, I took a calculator and he says,
No.
I provided you with one. And actually, the one they had was better than the one I had.
There you go. So that one may have the square root sign, but if you know square root will bring you 1.732
Okay.
if you forget about it or whatever. I know how it is in there. You've
Yeah.
got everything all under control, and then all of a sudden they say go and you just go. I'm screwed.
Yeah. He like my Tom Henders keyword
Hmm.
book. He's like, never seen that. That's cool.
Oh,
Uh,
really?
yeah.
Oh, that's
My
awesome.
uglies book, because
Uh-huh.
like you said, leave your uglies book face up, don't touch it. Is right there. He goes, it's a book. I don't care.
Yeah.
Uh, the only thing he said was that if you have mints, cough drops, or chewing gum, he says, help yourself, don't make noise, or
Yeah.
leave the wrapper there.
Yeah. Gotcha.
And that bothered me. He says, people will unwrap chewing gum, make notes in the wrapper. I said, if they're that damn smart, they should be able to pass the test. He said, exactly.
Yeah. Yeah.
And he must have seen me struggling because he come in and right next to me set a folding table.
Uh-huh.
That was just in a little cubicle,
Right. Yeah. Yeah.
which is actually no bigger than my desk that I'm sitting at now.
Yep.
And because I like fold a book, set it down by by the table leg.
Right.
And so once I was in the room by myself, he'd come in and scoot that table right over and grab one of my books off the floor and set it
Yeah.
on there and tap the shoulder and gave me a thumbs up.
Yeah.
So I mean, he was cool.
That's nice. That's
So
good.
I had a 10,000 watt motor operating at 208 3-phase. All right. So 10,860 times 746.
Now it's looking for your power factor.
No, so I'm jumping the gun in.
Yeah. Exactly. Let me see. What do we do? So all you got to do is take your power factor, and I'm just showing you that because this is a rarity question, but you take your power factor and pull it over here where the nameplate rating and then stick the nameplate rating back where you took your power factor out of your equation.
Okay.
And from what I'm hearing, you may not have it. You probably won't see this. I'm not saying you won't, but just take your nameplate, put your nameplate in, and then put your power factor there.
Okay. So my nameplate is
Let me see. Is this it?
33 amps. At 100% efficiency.
Okay. So right away, that's not the answer.
Yeah.
So let me see if I have it right here. There you go. And here again, I'm just getting this on your recording. So when you go back and study this, you can dive into this deeper. I've lost your sound. I can see you talking, but I can't hear you talking.
How about now?
There you go.
Okay.
Now, so that's your power factor and your efficiency. Let's get to our flow chart that you have in your book. That looks something like this.
Okay. Actually, I have that on 432.45 at the bottom as well.
There you go. There you go.
A little bit rougher than the one I did in the back, but
Hey, you're fine. You're fine. And let me get mine out so we can get exactly. So for step number 1, which is your FLC, we know where that's at. You've got your tables back there, correct?
right.
So what you may want to do is, let me see if I can show you this. Ah, it's not going to do it. At the top of 430.250, the table,
Okay.
what I was
430.
trying, it's the table for 3-phase motors.
Yes.
What I did and what you need to do is put step number 1 just somewhere on there. It's a note for you. Step number 1.
Okay. I usually do that in red ink pen. I can't find my red ink pen. Step number 1.
Yes, sir.
I'll go back and trace over it later in the red.
There you go. Or we can go through it and you can, whatever you need to do. Now for step number 2, which is your overload protection, which is your heaters, we need to go to 430.32A through D. 430.32. Let's say that right.
Yep. I have this marked second step, so I've already.
There you go. Exactly. So that's what we're doing right now. We're going through and marking these steps because you're going to come to this flow chart and see what they're asking. And then you're going to be able to go, all right, I've got a note here. And also when you wrote this, not only the flow chart, but when you wrote in your book, did you put them step 1, step 2, step 3, but then also put your code references next to those steps when they're all together in your book? If that makes sense. Or you can go like right down here, step number 1, FLC, and you could write you a little note there. It's 240.250 or 248 or whatever, you know, that gets you back to your tables. And what we're trying to do here is we're trying to make up a little bit of time so you're not having to remember all this stuff. It just comes to you. It's right there.
So step 1 is 432.45.
250. It's the tables. It's the tables back there.
Yeah, and step 2 was 430.32.
Or yes, correct.
So okay, I got that noted on the flow chart.
All right. I just want to make sure that when you see this flow chart, whichever flow chart you have, that you've got enough information to get you there right away. Heck, you could even put your page number on there if you wanted to, you know, depending how deep you want to go, so you can go quick. Because what we're doing is, you know how to do this. Now let's just make up the time.
Yeah, get it done. And
yes, sir. So step number 3.
Yes.
That's 430.22 for the single motor at 25% of the FLC. 430.24. And then you take it and go to 310.15B16.
So 430.22 is
that's the code that's telling you have to take 125% of a single motor.
430.22.
We went over that in the beginning.
Yeah, and this is step 3.
Yes, sir.
Okay. But step 3 could also be several motors. That's going to be like a step 3A and a step 3B.
Well, and then if it's several motors, you take 125% of the highest motor and 100% of the remaining.
Right. Run them all
And,
together, and there you go.
and then step 3. Now remember, step 3 is right. Let me get it. Sorry, let's go back. Step 3 is right in here. Let me just right in here.
Mm-hmm.
So that's the conductors. That's the wire size. So if we go back to, we still have to go to 31015 and pick our wire size.
Okay.
So it's the branch circuit conductors. And remember, when you're doing your motors, you use the 75-degree column to pick out your wire size. Don't use the 60, don't use the 90, use the 75-degree column.
Okay. Yeah, I struggle on conductor sizes too.
Okay. All right.
All right. So the 125% and the rest of them together, blah, blah, blah. That's already impregnated in my head for some reason.
Great.
So I just have to remember that that's what it is.
And it's step 3. Now, step 4. So let's walk through this. We've got this situation where we've got a 20 horsepower 3-phase, a 15 horsepower 3-phase, and a 10 horsepower 3-phase. Service factors are the same, and voltage is the same. So for step number 1, we go back to 430, 250, and look at our FLC.
Yeah. So 27 or 20 horsepower, 480 volt. 20 horsepower, 480 volt is 27.
All right. 15.
Yeah.
15 horsepower
15,
and a 10 horsepower.
Going to be 21, and the 10 will be 14.
Okay. And now we've got to determine our overload protection on those motors. And that's where 430.32A1. So we got to remember to look at our power factor. Or I mean our service factor, I'm sorry. And according to our question, our service factor is 1.15. So we take our FLC at 27, and according to this table right here, we multiply it times 1.25%. So if you take 27 times 1.25, what do you get?
33.75.
There you go.
Okay. Then the 21 times 1.15, 24.15.
Did you do 1.15 or 1.25?
Did 1.15.
No, 21 times 1.25 because of, and what I'll do, I'll take because of that right there. Remember, your 15 horsepower has a 1.15. Now be careful, because they will give you that option of an answer. So just remember, keep it at 1.25. So you got 21 times 1.25, and then you should have 14 at 1.25.
17.5. Yep, that's what I
Go.
got.
Excellent. Excellent. I see what you're doing. I'll try to keep the answers off the page until you work it out. I'm the same way. I got drifty eyes. So that's your heater settings, your overload protection settings. Now we got to find that wire between the motor and the MCC or the motor control center or whatever. So that's what we're looking for on number 3.
Okay.
So we got to go to 430.22. Oh, shoot. I told you I'd not show you that answer. 430.22 and take 20% or 125% of the FLC of the motor.
Okay. So 430.22.
Yes, sir.
So we got to do
You go
27.
back to the 27.
Yep. So it's 27 times, what was it?
1.25.
33.75.
Yeah, which we've already got that right here. We already established that right there. Now we got to take that 33. Oh, did I lose you?
Nope, I'm here.
Okay. I lost you somewhere. Oh, there we go. Okay. It was on my end. So we take that 33.75, but then we remember we got to go back. We're looking for that wire, and that wire's in 310.15B16 under the 75-degree column.
310.
310.15B16. And it was 33.75.
What was that table again?
310.
15B.
Yes, sir. 310.15B16. If you have your you're in the 20, right? Or the 23?
17.
17. All right. Then it may be a different location. It's right around, it's your conductor size. Let me
Doctor
see.
general use.
Yes.
Do you have it up in your 2020?
Yes. 310. Let's see where we at. And it should read ampacity of insulated conductors, not more than 3 conductors. Table C, it's 316 in a 2020 310B. So it should be like a full page. Did you find it? No?
310.60. From the table, allow ampacity insulated conductors rated up to including 2,000 volts.
Yes, sir.
Yeah, so it's 310.60 in my book.
60?
Yeah, 310.60.
No, I think you went too far. 310 16 or 310.16. I don't have my 17 with me.
Yeah, I go from 310.15B, 15B. Then I skip to 310.60.
310.15B's ambient temperature.
310.15B Adjusting factors for more than 3 current carrying conductors.
Okay. All right. 31015B. And then the next, what's the next table after that? 60? No?
I go to 60. That's conductors for general wiring. Formerly 31016.
There you go. That's it. That's
Yeah,
it.
just did.
So you've got your 60, 75, and 90-degree columns there.
Yes,
And then on the left-hand side, you have your wire size.
that's correct.
Okay, great. All right. So what we came up with was 33.75.
Yes, so we have to round up to the
Well, no,
35.
don't round. Don't round yet. Now you got to go down into your 75-degree column, and you just got to skim down to see where 33.75 will fit.
At 35.
Yes.
And
And then you
that's
go, then slide over to the left and find the
Yep.
wire size.
Yep. Number 10 wire.
There it is.
Okay.
And we do the same thing for the other two also.
All right, so that'd be 26.
Mm-hmm.
Yeah, and you're in the same category because you are rounding up.
Mm-hmm.
And the 17 would actually put you at 14 gauge.
26. Now, but you need to look on your number 10, number 12, number 14, number 16, and number 18 on the left-hand side. Do you see that?
Your wire size?
Yes, sir.
Yep.
There's an asterisk next to them.
Okay.
And what that's telling you is number 14 is only good for 15 amps. Number 12 is only good for 20 amps. I'm just paraphrasing the notes that are below.
Okay.
And number 10 is good for 30 amps. So if we use 26.25, that's above 20 amps. So that tells you right away that number 12 won't work. You got to bump it up to number 10.
Okay. And if I was wiring this, I'd keep it on number 10. I'm not going to pull a 14 or.
And that's where we got to be careful when we take the test. We gotta answer what they're asking, not what we would do.
Right.
It gets them every time. It gets us every time. So we got number 10s. And then with that same thing being said, with the asterisk, we know that number 14 is only good for 15 amps according to the asterisk. So we got to bump it up to number 12 because 17.5 is above the 15 amps.
Yeah, so I had to remember that on the test. They could give me.
No, they will. Not they could. They're going to give you that option. I guarantee you. Remember, those people are in the business to test you, not to pass you.
Yeah.
All right.
One of those is online. Electrical code something.
Uh-huh.
Brags about being on the panel.
Yeah. Oh, yeah.
I just think he's a hypocrite because he's on the panel designing the stuff, but yet he's out here teaching it.
Yeah. 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 I know 1, 2, 3 or 4 guys that are on code making panels, and some of them are cool and some of them are just like that guy. Some of them just get carried away. So let's go to step number 4. And what this is, that's your fuse that's protecting your motor. So this is your disconnect. This is your feeder to your panel. This is the fuse that's protecting your conductor to your overload to your motor. Is kind of how I forgot to go over that with you. So this right here is how to pick your fuse size to protect this motor right here.
Okay.
So branch circuit protection.
So 430/52.
Mm-hmm. Is that all right? 430/52. Let's go.
430/52. Maximum rating or setting of the motor circuit, short circuit, ground fault protection devices.
Exactly. Exactly.
And
So make sure you put
step 4.
step. Yeah, I was gonna say make sure you put step number 4 on there.
Okay.
And of course, we didn't put any type of whatever type of motor it is, based on the FLC and type of motor. So you'll have to pick your type of motor. But the next thing you have to do is make sure that you go to table 240.6A. And this table throws us as electricians that have been out in the field forever for a loop. What that is, 240.6A is your overcurrent protection size, your standard size. So that tells you what size of fuse or breaker to use.
Okay. And this is part of step 4.
Yes, sir. You bet it is. Because
Okay.
they'll throw a curve and maybe there's a 25 amp fuse, but who uses 25 amp fuses in the field? Let's just round it up to 30 and call it good. Well, there is an option of 25 amp fuses. I'm thinking, and I'm just thinking, I'm trying to remember what that table looks like exactly, but and that's where they're going to get you. They're going to give you a 25 amps or they're going to give you 30. Yep, yep, exactly. Remember that table. You're going to use that table a lot because they're going to throw a bunch of overcurrent protect. You know, if they throw overcurrent protection at you, something about picking the overcurrent protection, make sure you go to that table.
Okay.
Make sure you know where that's at. That's a very important table.
Yeah, that's right at the beginning of 240. So
Yes, sir. Yep.
okay.
Yeah, remember where that's at. I can't stress. So refresh on step number 4. All we do is we take the FLC and it's going to give you the type of motor. And then you take that factor, that service factor, and put that in there. Let me get back to motors. What was that? 430/52. So they're gonna, on the left-hand side there, they'll tell you the type of motor.
Yep. Single phase, AC poly, squirrel cage.
Okay. Remember polyphase is just another fancy word for 3-phase.
Okay.
That's 3-phase. That's all it is. And then they're going to tell you what type of overcurrent or overload overcurrent protection, you know, a non-time delay fuse or a dual element fuse, and you just go across to that column. And then if say we're doing dual element fuses, and then we'll go down, it looks like it's mainly 175 percent. And remember, it's a percent because it tells you right up there, percent of full load current in the top section of that table. So percent means it's going to be a multiplier. So 175 will be a 1.75 multiplier.
I put a big old fat percentage sign right in the middle of that table.
Yes, sir. Yes, sir.
Okay.
And then you take that number off of your FLC. Say it, let's just say it's 175%. You take your FLC of your motor, multiply it times 1.75, take that number, whatever that is, and then go to 240.6A to pick out your breaker size.
Okay.
So that's step number 4.
All right. So on 430.52,
Yes, sir.
note step 4,
Yep.
also 246A,
Yep.
round
Yep.
percentage.
Yep.
So I really haven't used any other color highlighter, but I did use the pink one on the percentage. So hopefully that'll stand out in my head.
Okay. Let's go to step number 5.
So is the 1.75, 175%, is that the number we're looking for on these? Or have
No,
we not?
no. On step number 4, step number 4, you're looking for a breaker size, that size that comes out of 240.6.
Okay, so we're looking for,
So we don't have let's see, the FLC of this motor is 27. Right?
standard ampere ratings.
Okay. Let's start at the very beginning of step number 4.
Okay, please.
We start off with our FLC. See, that's why this is very important to know where your FLC is. So this is a
Okay.
3-phase, so it's in 430.250. And we've already found that, and it's
Okay.
27. Now we bring it over here to step number 4 and say it's what did I say, dual element polyphase
Yes.
motor. And that's going to give us a percentage of 175%. So we take our FLC, which is 27, and multiply it times 1.75.
47.25.
47.25. Now we take that 47.25 and we take it to 240.6. Is that right? 240. Yeah, 240.6 to look for your overcurrent protection.
240.6A.
Yes, sir.
All right, why does this chart confuse the daylights out of me? All right, so it's 47.25.
Uh-huh. And then 240.6A.
Yep, on a table 240.6A. Okay, yeah, double checking myself.
Uh-huh. And that should give you an overcurrent protection rating. So what size fuse would you use?
So I went for 47.
So you don't have a 47 in there.
So I got to go to a 50.
Yes, sir. That's it right there.
So it's just 50.
Yes, sir.
Why that chart is so for me? Oh, okay.
So this breaker, this fuse right here in this main motor control center, or whatever this is, you would put a 50 amp fuse in here to protect this motor.
Okay. And the same with the middle one.
Yes, sir. And the same with the bottom one. And that's step 4.
Okay.
Step number 5. And I don't know what happened to my slide, but I don't have a slide for 5 or 6, but it's easy. Step number 5. We are looking for the wire size, the conductor size between the disconnect and the MCC. So the main disconnect is feeding the MCC, the motor control center.
Okay.
We need to know what size wire we need to put in there, because we have to supply 3 motors off of this
Correct.
wire right here. So what we've got to do is we got to go to 430.24 and make sure you mark that step number 5.
Several motors and or a motor loads.
Yes, sir.
Okay.
Yes, sir. So make sure that says step number 5. So what we've got to do is it tells us we got to take 125% of the largest motor, 125% of the FLC of the largest motor.
So the largest motor was 27 at 125%.
And so we've already got that FLC right here, which is 33.75.
Okay.
Now, note number 2 or rule number 2 tells us to take 100% of the FLC of all the other motors.
Okay. So that goes back to the first thing that I memorized. So step 5 should be.
So step 5, so you got 21 and 14 in this situation.
Yep. And that's 35. Then we got to do 27 times 1.25, which
And
is
what'd you get?
33.75. So full load is 68.75.
68.75. Now that's your amperage. That's the amperage that this whole situation here is going to draw. Now, but we're looking for the wire. So we need to go back to 31060. Is that right in yours? In year 17?
You said 31060?
Or 16? Well, I'm looking for your conductors. Remember, it had the 60 degree, 75 degree, and 90 degree column in there. We were looking for the wire size. It had the asterisks between 18, 16, 14, and 12.
That was the one we were just doing a few minutes ago.
Yes, sir. Yes, sir.
Or was it 31015?
31015?
75 degree.
Yes, sir. 68.75 was our FLC, or our amperage.
No, I don't think that was right. Conductors.
Should be called ampacity of insulated conductors with not more than 3 current carrying conductors.
There it is. 68.75
Yes, sir.
at 75 degree.
Mm-hmm.
So it goes from 65 to 85. So we're going to bump up to 85. And that's going to be 4-aught.
Not 4-aught.
4-AUG.
Yes. Yep. So now you've just figured the wire size that you need to pull between that disconnect and the MCC.
Okay. It's 4.
In step number
4-AUG.
4. I mean, step number 1, 2, 3, 4. Step number 5, I'm sorry, which is a number 4 wire. Now we've got one more step. We need to protect all of this with our breaker or our fuse. Usually it's a fuse at the main disconnect.
Okay.
So that's step number 6. And that's at 430.62.
Combined overcurrent protection.
430.62. Let me get in there. Um, let's see. It should be motor feeder short circuit and ground fault protection.
43062. Rating or setting motor load.
Yes, sir. Yep.
Okay. And this is step 6, correct?
Correct. So what it tells us there is we've got to take the largest rating of the branch circuit overcurrent protective devices. So the largest fuse that goes in here.
Okay.
The largest one plus the FLC of the all other motors. So in my notes, I don't remember what size fuse we pulled out of here. What do we have? Do you remember?
I'll ask you the same thing.
Okay. All right. We'll figure it out.
They weren't 50s, were they?
As soon as I turn to that motor, as soon as I turn 240, as soon as I turn to that chart, I'll see 240. I believe it was 50. So what we got to do is we got to take 50 amps because of that largest overcurrent protection, plus the FLC of all the remaining motors, 21 and 14.
$85.
You get 85?
Yes.
All righty. And now we have
plus 21 plus 14.
Correct. Yep. Yep. Now we got to go to 240.6A, that table in the front.
246A, you said?
Yes, sir. And now this, you've got to remember step number 6, they want you to round down to the nearest overcurrent protection. So we've got 85 for our math. And when I look in this table, I see we've got an 80 or a 90 on our overcurrent protection. So remember, we got to round down. So our breaker that would fit right in here would be an 80.
Okay.
That's it.
Okay.
Step six is kind of easy, but man, you got to do a whole bunch of other stuff to get to it. But that's it. Just take the highest overcurrent protection plus the FLC of your other motors, and then go to 240.6.
I don't remember any questions that were that drawn out. I don't remember a 20-minute question on there.
Okay.
Unless I just totally just blew past it and guessed. And
okay. And sometimes I've done that too. I've gone and I've failed a test and then went and studied and got the same question again and went, oh, that's what they're asking, So I understand.
Yeah. I mean, I got one on substations and I'm sitting there going, what the hell does a substation have to do with this?
Well, and now be careful. They like to get real colorful with their questions and get you thinking about all kinds of other stuff, and they're asking just a little simple something.
Yeah. I mean, you looked up in the book, it said the fence has to be 7 foot.
Yeah.
Overall. Chain link part 6 foot.
Yep.
And the 3-stranded barbed wire has to be what?
Yeah.
And it was a minimum of 12 inches. And I looked at the questions.
Right.
It was like 1 foot. And that's like my head wasn't converting 12 inches to foot.
Yeah. Oh, they love doing that.
Yeah, substation.
Yeah, they love doing that. They love taking 36 inches, but they give you 3 foot. Yeah. They get you thinking all over, and then you still got to take 12 and divide it by or multiply it times 3 and blah blah. Like I said, They're in the business to test you. They're not in the business to pass you.
Right.
So, so that's motors.
Okay.
That's your big motor right there. We've got overcurrent protection at your main disconnect. We've got our conductors from our disconnect to our MCC. And then we've got our overcurrent protection for each individual motor right here. And then we've got our conductors going out to our motors. As soon as we hit the motors, we hit our overload. Our overloads, our heaters are right here, step 2. And then our FLC is right here, step number 1.
Yeah, I don't know if I've ever seen a motor that had an overload on it.
Oh, you do. You will. They're not on the motor themselves. They're actually in your MCC.
Okay.
If you look, you've got your starter, and then usually right below your starter is your overload
Okay.
block. So that's where that's at. I know it for testing purposes, it's always this step right here, but in real life, it's inside your MCC.
Okay.
And then next time you're up against a MCC or a starter or something, you know, a panel with a starter in it, there should be a reset button on your door, and it's a plunger that goes in there and resets your overloads or your heaters.
Okay.
So that's where that's at. It's not in there's some internal, there's some little bitty ones, little bitty motors that have internals, but mainly they're in your MCC.
Yeah. See, I'm an electrician at a school system, so I'm trying to think where in the school system I would have the motors.
Um, go to your
Boiler.
mechanical room, and your HVAC stuff may have
Yep.
overloads on it. Now, if your school system has been brought up to date, they're usually running VFDs, and it's all internal within the VFDs of your heaters, or I don't know if you're running boilers or what some type of pump.
Yeah. Yeah. There are pumps there. It's all boilers. And all of those are new and they're maintained by an outsource. So I wouldn't even see it.
Yep. Yep.
So
So,
I don't even in the rooms.
well, if you could
I
slip
will
in that
now.
room and just kind of look,
Yeah,
and
I will now.
yeah, and look, and when you look, and maybe you've got a little circulating pump or something in there, you can do all of this. Now, you can look at that pump, find the FLC of that pump, and you can work all of that back to
Yeah.
at least to your MCC. You know, you don't know what else is on that MCC. There may be multiple motors on there, but you can work step 1, step 2, step 3, and step 4 off of that.
Okay. Yeah, I'll have to do that because I got to see
Yeah,
it in my head.
it's fun. It's fun. And then you walk out of there with a smile and a big old chest puffed up, and go like, "Yep, I got it.
Yeah.
I
Yeah.
got it."
Getting because all that's maintained by computers and
Yeah. Oh
you
yeah.
know, we have one guy and half of his job is just sitting outside the school on his computer,
Yep.
sinking in.
Mm-hmm. Yep.
Um,
Looking at the
and,
BMS or the building management system, making sure that building's running smooth, and yeah.
yeah,
Yep. Yeah.
yep. He
Yeah.
uses one damper to send more air down one.
Yep. Yep.
I don't want to know that. That's
Yeah.
why he makes that.
Yeah. Yeah. We're just the grunts out there with the tools on, keeping it
Yeah.
going.
Yeah.
Cool.
I mean, so okay.
So we've gone a little long, but that's cool. It's cool on that for our about an hour and a half.
Okay.
We can, what do you want to do? We can reschedule something. We can keep going and then send you a bill, or what do you want to do if you want to go over grounding?
Let's schedule something. Let me find my tabs.
Yes. Yes.
They're here. They're just not within reach.
Right.
Let me reschedule something. I'm taking my test on Thursday.
All right.
So let me schedule something
You schedule
tomorrow.
whenever I see it come through, we'll get on it and we'll go through
Okay.
grounding.
All right. And I'll get back in my grounding and I'll work through this probably tomorrow.
Yep.
Uh, it's pushing 7:30 here.
Sure. Oh,
So
okay.
I don't,
Yeah, it's only 5:30 here. So you're gonna wake up tomorrow going, how did I do that? So I will, by the time tomorrow comes around, I'll have you this video
okay.
and you can review and go from there. But
Okay.
I think we went over some good stuff and you've got it now. Now it's time to just practice.
Yeah.
So
Yeah.
you're good to go.
I'll just make me up a problem, and because it's easy when I sit here and look at the answers.
Right. Yeah. Oh yeah. Yeah. Yep. Yeah. Just go in there and change your numbers around and just work them. And I
Okay.
don't know those questions I sent you. I don't know if those have motors in them or not. But you've got it. So
Yeah. I printed all that out. So
yeah. Yeah. So
I'll go through here and see if I can find one, or I have the Mike Holt book, so I can find one somewhere.
heck yeah. Now you know how to work it.
Yes.
So
Yep.
you're good to go, man.
All right. I'll get on later on tonight and
Okay.
just reschedule something. And
Sounds good. I think this did you good. You went over, you got introduced to I think the little stuff that you need to pass, it's not going to take much. We picked up some time and we picked up some knowledge, so you'll be good.
Yep. And I'll find those tabs or buy more.
Yeah, exactly. Exactly. Yeah, get it tabbed.
I got the ones that were about yay big. I don't know if I should get smaller ones or bigger ones. I don't know.
Right. It's gonna be up to you. Up to you. That's you kind of trick that book out to yourself on that one. So
Yeah.
it'll be good.
So, okay.
All right, senor. All right, thank you. And
right.
I'll get this over here. I'll get this video to you and go from there. Please review it and keep working it.
Awesome. Thank you so much.
All right. Thank you. Have a good night.
Have a good night. Bye.
All right. Bye-bye.